In this video, we are going to learn backend for frontend pattern. Backend for frontend pattern basically separates API gateways as per the specific frontend application. In current design, we have several backend services which are consumed by the frontend applications, and between them we put API gateway for handling to routing and aggregate operations. But this makes a single point of failure. So in order to solve this problem, Backend for Frontend offers to create several API gateways and grouping them the client applications according to their boundaries and split them different API gateways. A single and complex API gateway can be risky and becoming a bottleneck into your architecture. Larger systems often expose multiple API gateways by grouping client type like mobile, web, and desktop functionality. Backend for Frontend pattern is useful when you want to avoid customizing a single backend for multiple interfaces. So we should create several API gateways as per user interfaces. These API gateways provide to best match the needs of the frontend environment without worrying about the affecting other frontend applications. The backend for frontend pattern provides directions for implementing multiple gateways. The main purpose of the using backend for frontend pattern is to provide client applications has a focused interface that connects with the internal microservices. For example, data consumption by a mobile user interface could be different from data consumption by a web browser. In that case, for better data representation, two backend for frontend pattern can be used, one for the web, one for the mobile. Let's have a look at the image on the slide with using multiple backend for frontend API gateways. There are three API gateways, one for the web, one for the mobile, and another for the desktop applications. So with following backend for frontend pattern, we have created three API gateways that can provide a different APIs tailored for each client application type. That means API gateways are segregated by client types. For example, in this example, mobile client needs different API requirements and can be developed specific APIs into API gateway mobile services. You can think product listing page and think that listing products, paging, sorting can be differentiate some specific case as per the client applications. For example, in our case, product microservices return product list. In web client UI, customer need to see all details of the product informations. However, in mobile client UI, customer need to see summarized data of data information. So these different data representation requirements need extra effort to adapt data for the specific client UI page. The frontend need to have some custom logic to reformat these data. As a solution, we can create client-focused interfaces with applying backend for frontend pattern. Backend for frontend pattern provides to move some of these frontend logic to an intermediate API gateway layer. This intermediate layer is the backend for frontend API gateways. When a frontend requests some data, it will call an API in the backend for frontend API gateways. As a result, backend for frontend pattern helps to improve user experience drastically. Therefore, it is an essential component when you design large-scale microservice architectures in order to consider data optimizations and aggregations while keeping the BFF focused on its frontend. So BFF has also some drawbacks. For example, when we put here extra gateway, that means it increases the latency and complexity. But if you develop large-scale microservice architecture, this drawback is not important than the benefits. Software architecture is always considering the trade-offs. So you should think benefits and drawbacks and calculate design benefits. As you can see that we have understood the backend for frontend pattern. So now we can apply this pattern into our e-commerce architecture.